My name is Paul Ormsby. I'm Chief Engineer at Overland Conveyor Company, and in this video I'm going to demonstrate the new Import DXF feature within Belt Analyst 16, in which you can import the entire conveyor profile, carry and return, including pulleys and everything, something that's new for version 16. So to do this, I'm going to use a drawing that I've already created within AutoCAD. You can see here it's actually a pretty elaborate drawing with quite a lot of dimensioning, information about the conveyor. You can see that's the tail end on the right hand side, the head end with, you can see there's pulleys defined. The location of pretty much everything along the conveyor is well known and dimensioned on the drawing. And I'm going to want to import this entire conveyor into Belt Analyst for my calculations. To do so, and I've kind of taken a leap here, and I'm not going to demonstrate how to use AutoCAD, it's not the scope of this demo, is what I've done is I've created a polyline here that is a closed polyline, and I just started here and drew every point along the conveyor where the belt line goes. I've drawn it in this case to incorporate the points of intersection of the curves. I didn't actually follow the curved segments, although I could do that if I wanted to. Just drawing to the points of intersection to see if I need to change those curve radii at all. When I've come to a pulley, I have drawn an arc at the same radius around those pulleys at the position they belong in a way that makes sense. And I've created a full loop. I've created a closed polyline that creates a full loop demonstrating the belt line. And then I've taken that polyline and I've placed it into its own layer. You can see there's quite a few layers in here, but I've created a layer called conveyor line that contains that polyline, and that's the only thing that layer contains. It doesn't need to be labeled that or named that layer, so to speak. It's just going to be in its own layer. And so when I'm done with that, I can go ahead and hit File, Save As, and I will go ahead and go to my desktop, and I'll call this Test Conveyor, and it needs to be saved as a DXF file. So I'll hit Save. I've already done this before, so I needed to save over it. So I've saved this file, and now I can close it because I know AutoCAD does not share very well with other programs when I have two files open. And now I want to import that into my Belt Analyst file. And the way I do that, the simplest way to do that is to go File, New, and you can see there's an option here to say Import a DXF file. And I can click on that, and there's two things that I need to tell Belt Analyst when I import this. The first is what was the units in which the drawing was saved. You know, what were the units you were using to create the length? I happen to know it was drawn in millimeters. And then what is the file? Where does the file exist? And it's testconveyor.dxf on my desktop. I can hit Open. At that point it asks me, so what layer that has polylines in it contains the information about the belt line. I know I saved it into my conveyor line layer, and I'll hit OK, and then it'll process the data and bring in the information regarding where everything is located. And in this case, it recognizes where the head is. It gives you a pulley diameter that was drawn in there, where there were other pulleys located, and where the tail is. Now, you're not going to have the opportunity within this screen specifically to define where the drive is, where the take-up is, where those bits are. It's just important to recognize where all the pulleys are, and more specifically, did it get the head and the tail correct? And in some cases, in this case, I know that the drawing was left to right, head to tail, and in reality, Belt Analyst always likes things left to right, tail to head. And over that length, it dropped 17.2 meters, or feet actually in this case, since I'm in English units. And I know that actually this conveyor goes up. So I can hit reverse, and I know that it actually is going to rise 17.2 feet and travel 676 feet from over the length of the conveyor. And it's logged all the differences there. I should note that if I have incorrectly selected the units in which the drawing was created and re-import it with the incorrect units, Belt Analyst automatically recognizes that, hey, that doesn't make much sense. it's saying if you import it like this, it seems the DXF file is saying it was drawn in metric units, and it's assuming instead of 32.83 inches, it's saying the pulleys are 32.83 feet. So clearly that would not create a reasonable conveyor, and Belt Analyst recognizes that and says, are you sure you want to do this? In this case, I kind of think, no, we don't want to do this. It makes more sense that things were drawn in millimeters, and you can always go back to your drawing and recognize that, and measure it and make sure that it is 676.2 feet as my output, and I'm actually rising in lift and do things that way. So I'll hit OK, and then it'll just ask me a simple question: where do you want to save it? I'll go ahead and save it on my desktop next to where the drawing is, and you can see 676 feet, 17 feet of lift. It gets my profile in correctly. I can look in more detail at the detailed drawing. You can see I've got my curves labeled in there. Again, the curve radii was not imported. It just grabs the PIs because that's how I drew it. So Belt Analyst is doing calculations for what the theoretical curves radii might need to be and filling those in themselves. It's got the pulley locations correct, and you can see relatively well how well it did. It did do something in this case where it added the drive at the tail, which I know isn't correct on this conveyor. So very quickly, I'll go ahead and fix that. I know my drive on this conveyor is actually at the head, so I'll click there, go to Edit, make this a little bit bigger so I can see all my buttons here, and say convert to a drive to make that guy a drive. And then I'm going to go to my tail pulley and say that's not a drive, that's actually a pulley, so I'm going to convert that to a pulley, and so it takes the drive off the tail, and I've added it to the head. You see my tension profile looks more reasonable at this point. You can do the same thing if the take-up is placed improperly, although it did it correctly in this one. I can always click and on each of these pulleys and label them and make them whatever they need to be. So that's importing the full profile from a DXF file, and I think it's relatively easy. Again, that's new for version 16. Of course, you can always import the old way, just the carry side, and that's accessed in the same way where you right mouse click on the grid and import from file, and you could choose just to do the carry side as well. So with that, this demonstration is over. I hope you like the new feature.